stuff, but we will also build the autoencoders, like how it will work, what they do, and what architecture when it comes to technical aspects we follow. Then how do we train the data, what data we test, what are the real world application of it, and why it is so crucial to learn autoencoders in the current world, and some advanced concepts that can be learned later. So this would be a complete hands-on session. So in the coding part also, if anyone feels difficult or any doubts at any time, you can just stop me. We will go slow and understand as many concepts related to the autoencoders. So if at all, if you miss me in any point, you can stop me. Or after this session, I would share you a hands-on notebook where you can just run and understand the things. So I've created an interactive collab notebook also for the future reference. If you just run those, you can just get to know so many things about autoencoders. So without wasting much of the time, so let's start with today's session. So that's called complete autoencoder tutorial. So what is autoencoders? So any of us have heard about the autoencoders before this session? Has anyone heard about the autoencoders? Okay. So first, before starting the topic, let me give you what are the contents that I would be explaining it today. First, I would be explaining what are the autoencoders, how do they work, and how do we build our first autoencoder. So to build technically, first we need solid planning. So that planning also will be doing. So then we would be training and testing MSNIT and return digits data set. So then we're going to discuss about the real world applications. Then step 6 would be to give you more insights on the advanced concepts that's going on currently, so that you can improve it from here. So without wasting much of the time, so let's start with what are autoencoders. So we all would have seen the photocopies, right? So whenever we see autoencoders, so autoencoders is one of the special type of neural network. So why it is very important is, so this autoencoders especially learns to copy whatever the input into its output. For example, we would have seen the smart photocopies, the input we would give. So even the output would also be the same. So something like a smart photocopies. Okay. So what is the difference that this autoencoders create? So if at all I can give you a overall architecture of this. So in the autoencoders, coming to the machine learning and AI, so to be more precise, neural network. So we would be feeding a image, that 28 by 28 cross image. So it goes through an encoder and it gets compressed, then decodes, and we'll get the final output. So when I say autoencoders, what are the key concepts involved in that? So encoder, what is an encoder? Why do I need that? So all those questions comes into our mind. So if at all, first if we understand this architecture, going ahead, the coding part and the other stuff would become very easier. So first, if I'll have to explain you what is an encoder, whatever the input that we give will be of heavy size. Image means it is not just the pixels that is been there. So it is a combination of the metadata as well. If you click one picture from your camera, from your phone, if you try to extract the metadata in that, you will get lot of details, like at what location you have clicked, what is the aperture of the image, and so many metadata would be hidden inside an image. So for that we would use autoencoder to compress into smaller representations. Like why this is required is, whenever you are, yeah, uh, any doubts in till here? Okay. So into smaller representation. Whenever we are processing into the cloud, so if we take the big image, huge image of 8 MB, 9 MB size, and if we start processing, the cost of processing would be very, very high. So that's why we would use an encoder to process any of the image before actually we compress it, right? So then what is the bottleneck here? So if we do a post compression, the image would look as is, the clarity will be as is, but still we achieve a good output based image. So for example, if you have seen the YouTube, so for example, if you go to the YouTube, you play a 7 minutes or 8 minutes video, so there would be something called thumbnails. So YouTube uses a similar autoencoder technology where although the video would be in 4K, the size of that would be in GBs, but it extracts a bit of it and displays it as a thumbnail using the autoencoder technology. So next part is why autoencoders actually matters, or what are the real world impacts of it. So one best practical application of it is, so in the healthcare industry. So in the healthcare industry, if we see, so uh, we would have seen the MRI and CT scans. So all the images would be very blurry and so much of noise would be there. So in order to properly analyze, so this compression technique and this neural network based autoencoders are very useful. Similarly, enhancing the X-ray image quality. Sometimes, if we see for in few of the old peoples, there would be some fluids or something would have filled. So that would be very difficult to analyze the X-ray images. So for that case, also autoencoders would be very useful. So next, detect anomalies in the medical images. So coming to the technologies, so we would have all used the Instagram filters, right? So we would have taken a photograph in the Instagram. That photo would be very blurry. So we all might have used the resolution increaser in the Google, right? So if image resolution increases means the clarity will also be good. So as I told you, YouTube also uses this video compression techniques and also voice noise reduction. So this is not just limited to your audio or video, even in the voice processing, this is being used. So coming to the industry, right? So quality control in manufacturing. So whenever they're manufacturing something, so any products they're packing or something, if at all it gets disturbed or package is been modified, or if it's not properly taped, so all those things can be detected in this. Then fraud detection in banking. So with proper patterns, so this autoencoder neural network helps us to flag the fraud also, and also cyber security anomaly detection. If we see in the recent, there is a trend of Ghibli art. So many of us upload our photo and it generates a corresponding Ghibli art also. So what cyber security anomaly they mean is, inside the photo, as you are aware, we can feed the metadata, chat GPT or Gemini. So it doesn't read it as a photo, it treats it as a bits, as zeros and ones. So and in that, if you hidden some text message and if you pass it, so that would read the text message as is and it will modify your image. Let's say you put a dog image, and if you ask it to convert it to a Ghibli art, that was your prompt, but internally you give inside an image metadata as convert this dog to a human, that would follow whatever the metadata that's been given inside an image, not the prompt. So this is for the AI security also, cyber security anomaly. And when it comes to gaming, right? So we all would have played a lot of games, PUBG or Clash of Clans or Candy Crush. So improving the texture, saturation, all those things matters. And also animation based frame generations, like you would have seen cartoons. There also we going to use autoencoders mainly. So here we have seen so many applications of it, impacts of it. So we're going to build a small part of it that can be used for a big applications, right? So before we go for the further thing, first let understand how do they work. So what is the learning process of this neural network? We know, we have seen what is an autoencoder, how does it matter in the real world impact. So if I'll have to explain how do they work, so that we'll get the clarity why I should learn autoencoder and where I can upload, where I can apply this autoencoder concept. So the learning process is very simple. So for input, you would feed any network of an image. In this case, we're going to use one handwritten digit. Okay, handwritten digit. That means in a piece of paper, we would write 7, 8, or 9, any of the digits. Okay, so that is the one. Next, second part is encode. As I told you, first, whatever the input that's given, second step is it should compress into smaller representations. Then after encoding, we need to decode also for the security purpose. So what decode will do is it will try to reconstruct the original image. Encoding means when it's compressing, it would add some additional noise. So this encoded image, no one can read what exactly the image is. So if they want to know what is the final output, they can learn through the decoded image. Next, comparison. So always, whenever you have a medium, right? Whenever you have a medium called encoding and decoding, you would obviously compare what is the input that I have given, what is my output, is there is any significant improvement in that, or is there is any loss, or is there is any gain. So all those aspects we're going to check. Next, so in machine learning, we have something called weights. How frequently it should adjust to the data set so that I can get the accurate output, right? So if you don't adjust the weights properly, your model will never give you the results that you expecting. So adjustment of weights, this technique also I would be explaining. Next, repeat. Why repeat is, so all the machine learning models, as you are aware, would learn most of the things through continuous epochs. We call it as epochs. By feeding the data in batches, we feed thousands of data. By reinforcement learning, so this would become a master, and it will be able to process the image that you're going to give later, right? Any random image. So these are the key aspects of our autoencoder thing. So what it bottleneck forces is, so it will keep only the important features. Like as I told you, image consists of the bits, zeros and ones everywhere. So that would compress and keeps only the things that are common. It will remove the additional noisy things. So next I would explain what is the architecture to be more precise. So the architecture that we're going to build in today's session is, so for the input, we would be giving a 28 cross 28 cross 1 image. So using the Convo 2D and max pool technique, we're going to encode the image, compress the image, then using the decoder, so we're going to reverse the encoding pattern and achieve the output. So we will see how much of a size can be reduced by increasing the quality of the image, right? So that is the thing. So compression should be 16x smaller at the bottleneck, and so the challenge would be to reconstruct of 1 by 16th of the information. Basically, you would feed an image of 7 MB. So the output that you should expect is having a cleaner resolution image with almost 16x smaller bottleneck. So what are the technologies that we're going to use today? So as I told you, if we are working on any of the machine learning project, TensorFlow and Keras are the must. So because they provide wide varieties of libraries, which makes our lives easier with very minimal code, even with a basic Python knowledge, we can build a lot of interesting AI stuff. So that's why knowing this TensorFlow and Keras are pretty much very important. So why it is very useful is, as I told you, it's easy, powerful capabilities, and it's excellent for beginners and experts. And see, if we are using TensorFlows, it's not necessary that we should know nook and corners of the Python or ML or any other thing. So TensorFlows provides a very good documentation support and environment also. So it's very easy to follow up, and even the syntax would be very simple, like a plain English, I would say. So next, there would be some computation also. For that, we would need NumPy, right? We all would have heard about NumPy. So whenever there is a numerical computations, for example, images would always be in the matrix, right? Matrix. So that computational part can be achieved through our NumPy library, which provides wide varieties of mathematical operations for our data manipulation. Next, we would need some visual representations like how our model is performing, right? And what is the difference that we are seeing in the results. For that, we would need some charts or graphs to distinguish how our model performing, or what is the inhibitors that's pulling out from our model from performing well. So for all those things, we would need something called matplot. So as I told you, so we would be using MNSIT dataset, where it will have the dataset of 60,000 handwritten digits. So we're going to use the 60,000 handwritten digits for our autoencoders neural network tutorial today. So far, any doubt still here? So far, any doubt still here? Anyone, any doubt still here? Does auto
Sir, what is the difference between encoder, decoder, and generator and discriminator?
so encoder decoder, what encoder decoder does is, so basically we would be giving a set of um, patterns. For example, we would be using a convo 2D or a max pool filter. So that would had some noise, relevant noise, reducing few of the unnecessary filters, right? So based on that, the corresponding decoder would be a reverse proxy of that. So that way, our image accuracy can be achieved in a very easier way. So generators would generate the image, and degenerators, this part, this decoding part would be slightly different in that. So that's why we would be going with a fairly simple architecture of uh, max pool 2D and convo 2D process, where it would be difficult for us to encode and decode the images. So that we would be seeing in the practical implementation, like what would be the difference that would be causing from the traditional and the current one. So that we would be shortly seeing in the collab notebook. I would be explaining that part. So yeah, particularly we would be using MNSIT dataset for this tutorial. So yeah, so all things would be implemented practically, so that will have more clarity, like why we are doing this or what are the aspects of this, right? So what would be our mission is to clean up the noisy images. So first thing is, what we'll do is to understand how this autoencoders going to help us. So we're going to add some random noise to the clean images. Then like we would have seen the poor quality images, like how would we clean up or how would we scale up to a good conditioned images. So all those things would be seen. So as I told you, our training strategy is noisy images to getting a clean images. So we will learn how to or remove the noise while preserving the existing content. So if I will have to give you an overview of what we're going to do today, would be very simple. Our first step would be the data preparation, where we're going to use the MNSID data set of 60,000 images, as I told you earlier. Next, so we're going to normalize those pixel values to the range of 0, 1. So we will create a noisy version of the training, and we will also be um, bringing the encoders and decoders into action to understand how much of a efficiency we can achieve by that. So also we're going to build one model which can be exported, and later on that can be built on any front end or back end for that. So for that, we're going to use Adam optimizer and binary cross entropy, right? Lossless functions. When we are feeding so many data, so many epochs, so there will be so many loss. So to prevent that, we would be using few strategies. So that also would be explaining. So for the demo, right, we would need every one of you to have a collab notebook so that we can start in a moment. So we can start with the coding. I'll also explain you why each one of the step is important, or what they play a crucial role at every point, right? Basically, there would be some 6 steps. So if we are good with those 6 steps, so then we are mostly thorough with this concept. So as I told you earlier, we would be following a simple architecture where we would be encoding in the sense we would be adding some noise, we would be compressing the image, then we would be using the similar strategy for the reverse strategy for the decoding, and we would be achieving a more simpler, efficient model out of this. So what would be our expected results out of it? So based on the training metrics, we should see a loss decrease from zero point 0.6 to zero point 0.1 with the use of Adam, Adam and binary cross entropy. So we're going to validate all the training metrics too. So as I told you, visual results would be noisy image and clean reconstructions. So what are the preserved digital shape, digit shapes and readability, all those things we want to see. Next is in the normal images also there should be low reconstruction error or anomaly images, high construction error. So all this we'll see practically. So in this, the key concepts are like in any image, we're going to measure it in terms of dimensions, right? So if we, for example, if you want to compress a high dimensional data of 784 pixel to 49, so that can be achieved through our current architecture. So, and also like we would be doing the unsupervised learning also. So basically, we would be just solely dependent on the input data that we're going to feed for the learning of the model. So next, for the loss functions, as I told, so binary cross entropy for the optimizing of the pixel values. So and the reconstruction qualities. So next for the backward compatibilities, like we're gonna see how networks learn from the mistakes, gradient descent optimization, that is Adam. So and also we'll see the weight adjusting parameters. So earlier, as I explained, these are our real world impact or industry use cases. So without anything, we can see the advanced concepts. So this I would explain it in the last part after we jump into the coding part, right? So is everyone comfortable with Google Colab Notebook? Is everyone comfortable with Collab Notebook? Okay, great. So just give me 2 minutes. I'll just share the Collab Notebook we will start from scratch. Okay. Uh, if anyone wants any help in setting up collab notebook, also fine. You can just text it here so that will help you set up the collab notebook. Okay. So I'll quickly open one collab notebook. We can start this session. Just give me 2 minutes. I'll just share this collab notebook. Is my screen visible?
Yes, sir.
Yes. Thank you. So collab notebook we will be using. If anyone wants any help in reaching till here, you can ask me. I'll just show you again, like how do we navigate between the collab notebooks, right? Okay. So the first step of any project would be starting with what are the libraries that we want to use. And I'll just zoom in. And how do we set up the code so that we can start easily without any ambiguity going on. So first we'll define what are the libraries that we'll be using. So first of all, so we will be using NumPy. For that, it's just a import NumPy. So let's call it as NP. Next, as I told you, we would be seeing some metrics also. So for that, we would be using matplotlib. In that, we would be using pyplots. Next, we would be using TensorFlow also for the main deep learning framework, right? Next, we need Keras for high level API for tensors, right? For that, we need Keras. So import tensorflow.keras. Next, if there are any warnings, we need to capture that also, so that that would be efficient in identifying and fine tuning the models. So all the IE non-critical warnings, we can hide that. So if you run this, our first part would be set up. So we would be using NumPy, Matplot for plotting the graphs, then TensorFlows, right? We need to install the Matplot. TensorFlow, we will import the keras. From keras, we'll import model called layers. Perfect. So first we need NumPy, then Matplot for visual representations, then TensorFlows for the main deep learning framework. So keras for high level APIs of TensorFlow. So next we need layers for the building blocks of our neural network. So this is about the import part where we set up our project. So next part would be the data set. So as I told you, we would be using MNSIT, the digits, handwritten digits as our data set. So that one we would be using. So for that, that would be very simple. So Keras would be providing us that feature. So if you use just Keras dot datasets dot mnist dot load data, that's very simple. This is how you load the data. So with this simple method, you would load a data set of 60,000 data. So that is why we use TensorFlow and Keras for our applications, as the coding would be very simple, like a plain English, right? So once you have the data, right, from the Keras thing, so you need to split your data into training and testing data. So we will split this into training and test data. So X train, Y train, similarly X test and Y test. So once we split this, let's just run it. So as you can see, it is downloading all our data set and it is importing into X test, Y train, and X train, Y train, X test, and Y test. So next, further, we will use to build a neural network so that it learns better what are the images, so what are the pixel values, how it's going to learn all those things. We need to start feeding it from here. So for that, what we'll do is we'll slightly tweak our training and testing data for the compressing. So as I told you, all the images would be in pixels. So as we know here, we have taken the train data. So for the train data, what I would do is I would divide it by 255 pixels, right? So that's just a standard number. You can adjust it based on the compression techniques. So train, so we will first get the data type of this as type. This would be in the float, 32 bits data type. Similarly, we should do it for the test data also. Whatever we train, we will apply the same strategy for the test also, so that we can compare both the inputs and outputs at the end. Next, once after we normalize these pixel values, and as we know, always the pixel would be in zeros and ones, right? So once after we normalize and we build a neural network, the next step would be reshaping the data for our neural network. So we need to reshape the data. After that, we will add one channel dimension, right? So let's start with the reshape. Same, all these things we're going to apply for our train and test data. So X train would be having all our training data set. So we would be modifying or reshaping this. Reshaping this into 1 by 28 cross 28 cross 1. Similarly, we will repeat the same for the test as well. X test is equal to, so in this step, so just give me 2 minutes. X underscore train, X underscore test. So we have normalized it into the pixel range values. So that is zeros and ones. Then we are reshaping and we are changing the channel dimension by adding some grayscales with 28 cross 28. So next step would be to visualize some sample digits, right? Whatever data set we have imported, so far we cannot see what are the data sets that are there. So now we can visualize them. So for that, we can start with the fig. For visualization, as I told, we would be using matplot. ELT.subplots. Using matplot, we can specify these parameters. What are the figure size that we want? All those. Based on that, we would get the graphs. So we can get a fixed size anywhere between 15 to 3 pixels range. So now let's finally plot this figure. Fig dot, add some title to this. So let's call it as sample MNIST and return digits. So as we can see here, we have successfully plotted our graph, but still the images are not visible. So now we're going to write one function where all the images would be fit in here, right? So now we can see how exactly the images are there. So I'll write it for the first 10 images so that we'll have a clarity what is our data set looks like, right? So range of 10, we'll see what is the first 10 images looking like. So we will see how our training data is looking like, right? X train I, this would iterate 10 times and this would show us what exactly are the images looking like. So next we will set some titles also for this. Dot set title. Since we are taking the help of digits data set and we are analyzing. So let me call it as a digit. And let's take it from the Y train data set. Similarly, we will make this axis as off. So we'll just run this single digits. We'll add some font size to this. Yes. So finally, we got our first row. As we all can see here, so this is our data set is looking like. These are all the handwritten digits. So 5, 0, digit 4, digit 1, digit 9, digit 2. So we are using matplot actually to show our data set how exactly they are looking like. So similarly, let's pre-populate for the second row as well. So the second row also would remain the same. So what we'll do is we will increase the iteration to next 10 images. So these are the first 10 images. So I plus 10 will give us the next 10 images. Similarly, Y tray here also the next 10 images. So the all these steps are to see how our data set is actually looking like the first 10 samples. So let's plot this. Finally, let's ask this to complete this entire graph. So we can see here, this is how our image is going to look like, the data set that we are feeding. So the handwritten digits. So for this digits, we would be adding the noise and we would be denoising it, and we would see how to what extent we can compress this images. So we need the second row. So for that, we will take the index 1. Sorry. So this should give us the second row also. So as we can see here, the first row has different set of data and second row as well. So basically we are using matplot to plot and just represent how our data set looks like, right? So we just imported from this Keras load data. We never know how the data is looks like, or what is the um, data set having type like, right? So for that case, we need to see how exactly the data looks like and what are the strategies that we have to apply for this data. So if we see now, these are all the different handwritten digits that we have imported. Now, what we will do is one by one. First step is, as I told you, encoder step. So in the encoder, we will create some noisy data. We will add our own noise data here, and we will see to what extent we can compress the images, right? So we will be adding some noise factor, and we would be denoising also, and we will see how efficient is this auto encoders in practical. So quickly, let me explain the adding the noise part. So adding the noise is also very simple. We have certain built-in functions and noise factors which can be used to add the noise easily. So we'll just keep the noise factor to 30%. So we will generate noise using some random numbers, random normal values. So it accepts three parameters. So location, scale, and size. So we will keep this to the default values itself, which is 0.0, to generate the random noise, and scale, like how big you want the images to see. So the scale factor will keep it as 1. Then size, we will keep it to whatever the image original shape is. For that, we can use images.shape. So while we code, we can observe here, it provides a documentation also side by side, so which will indicate what each parameter is. So this entire step, we are using random numbers normalized function to add some noise. So how exactly the same data set would look like if we had some noise to the image. So this step is noise generation or encoding step. So finally, let's add the noise. Let's see like how we can add the noisy images. So whatever the images that we have, for that we would be adding the noise factor 30%, and we would be multiplying it with the noise that we randomly generate. Next, what we'll do is we'll clip a, see, whenever I generate any random numbers, it can generate to whatever values it wants, any number of values. So but our image doesn't recognize all those values. It is just restricted to zeros and ones. So it is necessary that we clip the image to zeros and ones. So this technique is called as clipping technique. Generally, we use it in our day to day for optimizing any of the data sets, or in this case, it's an image. So we also use it for audios also. So use the clipping technique, it's very simple. So NumPy provides us an inbuilt function called clip. So that will help us select the range of values between 0 and 1. So these are the two values that is required for us. Next, what this function will do is it will return the noisy images. So now let's get what is the train data set for noisy images. So xtrain, let's name it as noisy. We will add noise through this function. So we will just pass the images through this function, add noise, xtrain. So by default, I've given the noise factor as 30%. So we are free to change here. Whatever the noise factor that we give, that would be taken here. Let's say I give some noise factor of 40% for the encoding, right? So similar operation we will do for the test data also. Test noisy, and we will add the noise factor of 4 also. So what this step does is, so whatever the first thing is, we saw what exactly the data sets looks like. For that, we use a simple for loop, and we actually plotted those first 10 images in the first row, next 10 images in the second row. So basically, we viewed the data set. Then the first step is we imported all the necessary libraries for us. So here we successfully created the noisy functions. So next we will plot what is the clear versus noise is looking like. So as we can see here, although we added noise, all those, but we cannot visualize the image. Without visualizing, we cannot tell what is the difference between a noisy image or a clear image, right? So that's sake, next step would be we will compare what is the difference between, or how the noisy versus the real image is looking like. So for that, again, same. So we would be using pyplot or matplot for that. So plt.subplot, figure size. This time we can give it to 4 also. We'll give a title like last time. So this time what we will see is what is the difference between a clean versus a noisy image. If you want, you can add additional things also, like you can define the font size, all those things to make your visual representation more clear. So there are plenty of functions like font size, or even you can make the font weight as bold. So this is with respect to the plotting part. So now I will loop the 20 images in 2 rows to show the comparison, like how the noisy versus the original images looks like. Same like the previous one. So 0 indicates first row. So whatever is in the first row, we are accessing that. So for this, we will take the title. So train means we are taking the clean images. So let's name it as F clean. So these are the clean images. So you can add the formatting also, like font size, or even you can take the color also. Let's say I'm indicating this with the green, the clean images. And we will truncate the axis so that that would fit into our frame. Next, for the noisy image, similar row, we're going to repeat for the noisy images in the second row. Dot im show will help us show the image. So that noisy image, we have it in extrain noisy. Then if we reshape this to our 28 cross 28, even we can give a C map of gray. So next step is we will set a title. Similarly, first we will plot the image, then the title. So this title will contain noisy and color red, access off. So plt dot typeplot dot show. So now we should be able to see as no attribute subplot. Im show reshape cmap. Subplot. Subplot of, okay, it's called as subplots. Subplots. Just let me refer to this. Okay, we call it as subplots. Subplots. Let's close this. So cmap in this row, image, noisy, reshape. Across. See. Okay, perfect. So as we can see here, the first one contains the clean images. The second row contains the noisy images. So we can see here. So this is our clean image. Just a second. So these are the clean images. So we added subtle amount of noise to this. So train, reshape. So further on, what we will see is we will build the autoencoder architecture. Now we have seen how adding a small bit of noise looks like. So although it looks like very negligible, so let's see like how what happens if we apply our architecture to this. So as I told you, first thing is so we are building an axis, two axes for the plots. Second thing is we are setting the title for that. Next, using the for loop, we are looping with the clean data set versus the noisy data set. So this is what till here. So next is we will build our model. So to build the model, we will take a small function. So first is the input layer. We will go step by step. So first is we will feed the input image. So that we will get it from Keras. So we will name it as input image. Next, what we'll do is we'll first build our first encoder. First encoder layer of 28 cross 28 and we will reduce it to 14 cross 14. So for that, we would be using Convert 2D. Convo is a class. So Convo 2D model. So filters. After filters, we'll specify it as a 3 by 3. For the activation, let's keep it to ReLU. Padding. So let's keep it uniform. For that, we'll use the keyword as save. Next, we will name it as encoder. Convo 1. So this would be having our input image. Next is we would be max pooling this whatever the 2D images we have got to achieve the 14 cross 14 results. So for that also it's very simple. We'll use the layers. then max pooling function. So we will scale it down to 2 by 2. For this also, we'll keep the padding as uniform. And let's name it as, let's name this as encoder pool. Next, second thing what we will do is we will convert this 14 cross 14 to 7 cross 7. Further level of optimization. Further level of optimization. So this is our bottleneck. So what happens if we convert directly? So directly, if we try to scale it down to so minimal thing, so the image results would not be proper. So now we will convert this 14 cross 14 to 7 cross 7. For that also the same part. So we'll use the layers API from the Keras. Similarly, we will use the convert 2D. There we have used 32 filter. So here we will use the exactly half of it, which is 16. So the rest of the kernel size for the training and all will remain the same, 3 by 3. The activation parameter would be relu, the same one. Next, let's keep the padding as same. Next, finally, let's name it. Let's give it a name, saying encoder 2. Since encoder 1 is of scaled from 28 to 14 to 14, encoder 2 is scaled from 14 bar 14 to 7 bar 7. Next, finally, we'll get the encoded image using our max pool. Max pooling 2D. Since these are the 2D images. For this, we'll keep the kernel size as 2 bar 2. And next thing that we need to specify is our padding. So padding will keep it as uniform. Then we need to give a name, same step. So this would be our bottleneck. Bottleneck as in the final one. So now we have successfully built our encoder part. So second part is we need to build the decoder. So whatever the encoder that we have built, so basically that's the reverse engineering of the encoding part. So this is the encoding architecture that we have built just now using our convo 2D. We added the layers. So that what that in turn does is it will help us scale a 28 by 28 image to 14 by 14. Then further we are scaling down to 7 by 7, which is our bottleneck. So since we have completed the encoding structure architecture, now we need to go with the decoding part. So which is our third step, right? So decoding also would be similar. in decoding also we would be doing in two stages, just like how we did here. So first decoding layer, it will start from 7, as I told you, reverse of whatever we did in the encoding. So it will start from the bottom step. So 7 bar 7, we will scale it to 14 bar 14. This would be our first step, right? So we would use again layers API here, Convo 2D for adding additional layers. Then we would add a filter of 16. Then we will define the kernel size, same as is. Activation algorithm would remain the same. We will be using ReLU. Padding will keep the same, uniform. Next, let's give this as a name. And we would be passing the encoded image to this. So similarly, now we need to upsample this image. We'll use the layers. Inside layers, we have a method called upsampling 2D. So that will help us scale the images that we have passed in our data sets. So for this also, we will specify the kernel to 2 cross 2. And let's name this as decoder upscale 1. So we have built our first decoding layer, which will do 7 cross to 14 cross 14. So next we need to build our second layer. So second layer would be from 14 cross 14 to 28 cross 28, back to original image. So if we see again, we will use the layers API, same steps that we have done. We will add a combo layer for the 2D images. Last time we used 16 here for the filter. Since we are upscaling from 7 to 14, now we are upscaling from 14 to 28. So we need to use the filter 32 here. And the kernel for processing would be remain the same, 3 cross 3. Simple. So again, also activation would remain the same. We need to specify ReLU. Then padding would be uniform across. We are not playing with the image size. So next would be decoder convent. Similarly, we are upscaling this image also. So finally, what we should do is we need to get the decoded. Now we have done the encoder. Now we have coded for the decoder. So finally, we need to see what the output is looking like. So if I have to tell you, first we have fed one input layer. For that, we added uh, convolution layers, right? Different layers with the activation ReLU, where what that will do is it will scale down 28 cross 28 to 14 cross 14. Then further we are scaling 14 cross 14 to 7 cross 7, which is our bottleneck. Similarly, we whatever process that we repeat for the encoder, the same, the reverse of it would be repeated for our decoding also. So once after we complete with the encoding and decoding part, the final part would be the output part. So for the output also, since these are the 2D images, We will use convert 2D layers is the right thing. Convert 2D. Then we'll apply the filter. Same. We need to specify the kernel size. Then for the output, we would use a sigmoid algorithm. Padding, we will keep as is. Name it as output. So this completes our model. So we have built first is a encoding layer. So in the encoding layer, we have two subtypes. So one is having the 28 cross 28 image to scaling down to 14 cross 14. So in the second encoding layer, we are again scaling down to 7 cross 7, which is our bottleneck. As I told you, decoding would be our upsampling. So whatever is the reverse of encoding. So it would start from 7 to 14, then 14 to 28. So finally, we would be seeing the output, whatever you are getting in the output layer. So to complete this model, so we need to take a variable autoencoder. So Keras, inside Keras, we have a model API where we can pass our input image and also the decoded images. Then we can name this to autoencoder. This step to autoencoder. Next, once we create the model, next is we need to compile the model. So this is model creation step. This is how we create a model. This is very simple. So whatever the input image that you have and whatever the decoded output image you have, that you will be putting here. So this is the creation of model. Once you create the model, you need to compile to look how exactly your model looks like. So autoencoder, if we compile this, optimizer, then loss. Why we need optimizer as Adam is, so for Adam, whenever we use for the adaptive learning. So whenever we have certain kind of data, if it should quickly adapt to those, and if we want our model to learn at a better rate, so we usually go with Adam. So for the loss, we will go with binary cross entropy. So why? Because binary cross entropy, again, the binary says the zeros and ones. So which is very good for the pixel values. So which are between the values that we narrowed down to zeros and ones. So whenever we are going for any image or video related things, so always we prefer going for binary cross entropy for the last thing. Next, we'll collect the metrics as well. What is the accuracy of this? So finally, this model would be completed. So now we need to just call this to build. That's it. So now we have our built our model. So this is the building of model part. So next we can export this model and we can use it for our real world applications too. So this is the way we build a simple autoencoder model where if I'll have to brief it out again, so first is the input layer where we pass the set of images with this shape, right? So next we would be further reducing it to 14 cross 14 with a ReLU. Then we would be using max pooling 2D to further scale it down. So this is the bottleneck for 7 cross 7 images. So next we would be going for the decoding layer where the reverse of whatever we did for the encoding. So 7 cross 7 to 14 cross 14. Next in the second decoding layer, we are upscaling from 14 to 28. So finally, we compile everything into the output layer. So this output layer again will pass it to the model creation. So these are all the steps. These are the only steps that we use for model creation. So autoencoder.compile, as I told, we use Adam, binary cross entropy. Then we get the model accuracies too. So if I can show you one example of this. Yeah, I'll quickly show you the example of this. Just a second, I'll share that screen. So I'll just quickly share the example. So as we can see here, this is how actually our model going to look if we start feeding the input. So one is the input that we actually got, 5, 3, 8. These are the images. Once we added the noise, then after we denoised it. So this is the difference. So as we can see, the clarity of the image is also increased significantly. So for the these kind of low, I mean, this data set is very small since it's a day 60,000 sample pool. So that's why we can just go for the conventional pooling techniques like max pooling or all those things. And we can achieve this when we go for uh, the advanced model. So we can directly integrate to any of the higher LLMs or a few Hugging Face models, which will be more advanced in training all this and giving us even more better output. So this is how our final output looks like. So I would be sharing this Google notebook also. So if anyone missed any part, so in detail I've explained everything. So that can be referred there also. So if I can quickly wind up sharing the final advanced concepts, so that will complete here. Just let me share the PPT. So just 2 minutes. Sorry, I just shared the same screen again. Just give me a second. I'll just share the screen. Yes. So as of now, since we had very less time, I could able to explain what are the architecture, how we use make use of Keras libraries like layers, and how to add layers, and how to use the same layers in compressing the image. All those things we have discussed in a very short span of time. So if we want to further excel in the neural network, or building the Gen AI based applications. So these are the few things that we need to follow even after this tutorial. So first thing is, I'll be sharing the link of the collab notebook that has like a complete a description of each and every line of code, so that even a non-coders should get benefited, like what exactly the things are there, like how exactly we use the techniques in the industry to optimize the things. So all those things would be mentioned there. So next thing is, there would be a pickle file in that, where you can use your own where you can use your own images, like you would have your own blurry photos that also you can upload, so you will get the output. So all those things can be achieved here. So, and also we have used a lot of libraries, right? NumPy, Keras, and Matplot. So in a very short span, understanding all those, like what exactly a model is, what exactly a data set is, how exactly we are getting 60,000 images just by one line of code. So all those things we can explore it from Keras, and Keras documentation, even NumPy, or even Matplot, how we can plot those, and what the syntax means. So all those things we can explore it here. So, and also if we want to like get more understanding on the neural network part, not just theoretical, also building the practical oriented. So there are few courses also which I've recommended. I've added it here, which are free, that can be taken, that will give more understanding, like deep learning, as in the recent, whatever the recent advancements are there. We would have seen Google has launched their new model for the image generation, which is very good compared to whatever the GPT model, or you would have heard about Grok. So Grok, the Twitter AI bot. So it is even better than that. So it is having the latest courses in this. This would really help if someone is absolute beginner and want to have more knowledge in this domain. So this would really help. This is what even I was suggested initially to go through before I start my work. So, and also there were very good books by good authors. So Goodfellow, these books are really good. And the pattern recognition and machine learning, especially this book is very helpful. Why? Because like it will tell us like how we can recognize the patterns, and how we can apply the optimizers like sigmoid or relu or so many other things. So not just that, so there is a website called Kaggle, where we can get more data sets, more solutions basically. And also even we can get the more GitHub source projects, or also we can go with the Reddit or machine learning channel, like there, very frequently if someone is not using the Reddit, I would suggest them to use Reddit, because very whatever the new technologies related to machine learning comes in, the Reddit would be having it in prayer. The community, the people would be there posting, and this would really help for the teachers or the faculty members to stay updated with the current tech. Stack Overflow is very old, but still now we have a lot of AI tools for this. So I would strongly recommend everyone to have a Reddit account, and just subscribe to the machine learning community, so that you would be getting more knowledge day by day, that is happening currently in the industry, and what are the techniques that are using for image optimization or voice. So a lot of things would be seen here. So I would share this slide also, and I would share all these resources also, so that would be very essential, and you can continue, you can take it forward from here, whatever we learned here. So that would be really helpful. So there would be a small quizzes also, so that that would be shared later. So yeah, so let's, can we discuss this, how the force feature learning, all this, can we make this session interactive for another 10 minutes or 5 minutes? Can we address this, right? Can we discuss on those, please? Like you would have seen what are the bottleneck. So bottleneck, we scaled it down to 7 to 7. So the small, see how the bottleneck forces feature learning. So you have a big chunk of data, common type of data. For example, now we have handwritten data. So in the handwritten data, there were 60,000 samples. So in that, we started feeding in the small batch by batch, and we started reducing it to first to 28 cross, then half of it, then half of it. So what happens if we go even below the bottleneck? That is something, if we understand, that would be really helpful. So even to optimize whatever are the current models are there. So next, we have used different layers, convolution layers and dense layers. So as you can see, convolution layers, mostly we used it for the encoders part, where to add additional layers and make the image more encoded and noisy. So dense layers, we obviously used it for the downside of the descaling part, where the decoders, the upscaling of the images, so that part. So what happens if we make the bottleneck too small? If, like we did for 7 cross 7, so what happens if I make it for 1 cross 1? So all those things can be uh, learn through the Google Colab notebook that I would be sharing. So also the common challenge that we face is like overfitting of data. Like having a data is also good, underfitting of data is also bad, overfitting is also bad. Like how to maintain a constant amount of data. So that is also very important, and that related to that, we get more insights in this deep learning by Land Goodfellow book. So that's a really good book when it comes to understanding how your data. So if we understand what is our data, how is our data, what we have to achieve, so these parameters becomes easier. So if we have to discuss about the application ideas, so first we can see our surroundings, like what problems I can solve using these auto encoders. like uh, like it is not just image scaling or descaling. So there is a lot of things other than that. So first we need to identify one of them. So next, how would you adapt this for your field? So as faculty members, how would we adopt this auto encoders into our field? Is there is any thing where which would help us? So in our current project that I was working on, I was forced to use the auto encoder because the user generally uploads images, profile pictures that would have not the great quality. So to enhance the profile picture and make it as a good look, for that we were using auto encoders. So for that we are using Azure based model. So um, like as I told you, YouTube thumbnails, Instagram filters. Even in Instagram, you would have seen, you would have uploaded a bit low quality image, but that would automatically scale up to the higher ones. So this is something is in trend. So knowing this would make way for future learning, more future learning. So and also we can explore the different data sets, and we can try it out. So see, now coding should not be a this thing. So coding can be achieved through different AI tools like Cursor or also. So having the concept, the idea is what plays a major role at the end of the day. Even if I don't know basic syntax in Python, so still I can build an application. Many people are doing that using AI. So now having a solid foundation or solid understanding about the topic is more important than actually coding in the recent days. Coding is completely been done by the AI in the recent trends. So what are the implemental challenges that you're going to face? All those if you record, and how you can scale this to very larger images. Larger, you would have scaled down to some lower images, but sometimes there would be application where we need to increase the image size, image clarity, altogether everything. So even if you search in the Google like image resolution enhancer, so that also you can see you would have uploaded a certain kb of image that would scale up to so many kbs of image. So that also, like especially Adobe uses this technology more. So then what are the resources that are needed, and what are the measures for success, how I can build a successful model? So all these things are few of the things that we need to work on. So basically, at the end of the day, autoencoders are very simple on the surface level, but building for our problem is what makes us our use case more special. Actually, as I told you, one of my company use case was user would upload a picture, but that picture we cannot tell the user to upload a I want only this size image, this resolution image. So he will upload whatever he wants. So scaling of that image, improving the resolution, for that these encoders are really helpful actually. So I hope auto encoders, everyone would be using it going on. And also the collab notebook that I would be sharing would be very interactive, um, very interesting. So by running each blog, you will gain a lot of understanding in that. So that would be really helpful. So I'll just paste the link of the collab notebook that everyone can refer, so that even in your free time you can understand what each line of code is and how the behavior is for each one of them. So this is our first of. Till then, any concerns or anything that wants more attention or more discussed in this? I'll quickly share my collab notebook. So let's not stop it here. This is something being used by most of them in the industry also. Um, like they are spending so much bandwidth in educating related these kind of models actually. So this is something which is in tech currently. So which is hot topic. So I request all of you to actually refer to this notebook. Actually, this is I've took so much time to prepare this so that it has in-depth knowledge. Even a person who is not proficient with coding also should be easily able to know this. So everyone can take a copy of this and save it in your local system, so that at any point this can be deleted also from the drive. That's why. So I've included all the contents of the PPTs and in-depth knowledge of all the steps, so that even you can try it in your free time and you can also improve this model. So any questions till now? So this is our first talk, where we discussed about the auto encoders. Any questions? Am I
Hello.
audible? Yeah, ma'am.
Hello, sir. Hello.
Yeah, ma'am.
Sir, myself Rachna, sir, from BDT.
Yes, ma'am.
Sir, I just want to know about how to
Uh,
customize CNN,
uh,
sir. Meaning of customization, sir.
so you want to know the customization of CNN, right?
Yeah. Yes, sir.
So there are different levels of customizing the CNN. Like as I told you, based on the data set. Now we took a handwritten data set, which is a 2D data set. First, it depends what is the data set that you're using. Based on that, we apply convolution layers. That is our convert 2D, which detects edges, shapes, or different textures, right? So
Okay.
based on based on that, we apply the convolution layers. Next, we apply the pooling layers. So
Mm.
based on our input, whatever the image data set that we are giving, so we need to customize these parameters. So these parameters will lead to your customized inputs actually. And also,
Okay.
if you see
Mm.
for the customization, So you can build an architecture like how many layers you want to include, and what are the filters, what are the size. So then there is like activation functions, like as you know, relu, leaky
Good
relu,
morning. Yeah.
adam, all those things. So like this you can customize, ma'am. And
Okay, sir.
model doesn't build over time. Model is something which will not build only once. You have to keep on training, retraining your models by adding and deleting some layers, so that you will get a proper accuracy and lossless data actually.
Okay, sir. Sir, will it work even for the pre-trained model, sir? Can I customize pre-trained model of DL?
Yeah, you can customize pre-trail model. What you would need is, like, you need to play around with the changing the activation functions, then layers, then you need to regularize the things, like what is the dropout that you are adding, what is the batch norms. For that I have one good article. I'll just share it to you, so that would be really helpful, like the
Yes.
easy techniques that we usually refer whenever we are using CNN.
Yeah. Okay, sir. Sir, kindly
So
share, sir. Thank you, sir.
yeah, that would be really helpful, ma'am. I'll just share it to you. So
Oh,
even we
thank
also
you, sir.
refer to that. So that's a media market article. I'll just share it to you, ma'am. So there
Thank you,
you
sir.
have more insights. Thank you, ma'am.
Yes, thank you.
And also you can also go for if something like if YOLO also, you can try out with that also. So I'll just
Yeah.
share that article. I've just noted it down. I'll just get that article and
Okay.
I'll paste it here, ma'am.
Thank you, sir. Thank you.
Thank you, ma'am. So any other question? So if not, we can take a 5 minutes break, and we can start our next session where we would be using our custom data, um, and we would be building our LLM, right? So then, if we have time, I'll also show you how you can take that forward. Like whatever data you have, customized LLM that we are building using LangChain, how you can use external APIs like Gemini and all to optimize it even more, to scale it to next level, like how we do in our day-to-day work. So we can take a quick 5 minutes break, and we can start that, so that we'll get more time to cover that topic too. So that is something very interesting also. So yeah, we can take 5 minutes break. I'll start with that. So can we start with the other half of the topic where we build the LLM and fine tune it further with Gemini API? Can anyone confirm if you are able to see my screen and my audio is proper?
Yes, sir. Yes, sir.
Thank you, ma'am. So this session is primarily focused on generally, let's say we have a textbook that has, let's say, thousands of pages, and searching manually would take so much time and effort, and you need to scan page by page, right? So to automate that, we can use this architecture basically to search anything for your custom data. So that again, as I told you, we would be following the simple step, and we will see how exactly we can build. First, we will understand the architecture, the requirements, and what would be the end output would be looking like. So as I told you, this would be like a document Q&A with AI. So first, we would be building our LLM, local LLM. Then we will see how AI will help us in making our LLM more fine tuned. So LLM is nothing but so whatever, let's say you have a book written based on deep learning. So and you want to restrict your model. I mean, you trained your model specifically on that parameter, on the whatever the data that you have fed through PDF or text on deep learning. So that customized part is called as your language learning model. So that learns whatever the parameters that you have fed through your input. So that we'll see today. And also, as I told you, what we'll build today is you can upload any PDF or test document. You can ask questions in your natural language. What is natural language? So in simple English, like what is that and what is this, whatever, based on whatever the documents that you have uploaded. So you will get the intelligent answers and citations. See, you will get the answers, intelligent answers, but for citations you need to connect with Google API, that is Gemini, so that will do the scraping part for you. So and also, if we have seen AIs, right? So first thing is conversation memory. So you would be talking about some topic. We all would have used Chat GPT. So we would be chatting about something. So that remembers whatever we texted to that previously. For that also, I'll tell you what conversation memory that we are using to follow up questions and all. So next, we are going to use Google's free Gemini API, which any one of us can get and completely working system in just 30 minutes. So today, as I told you, I would be giving a sample text of related what is a Python and that. So based on that, I would just ask a question. So our AI or our LLM will provide our accurate answers. And why this particular thing is very important. So as we all know, as I told you, it would save a lot of manual work in searching the documents. So that would be very accessed instantly without having to scan through the entire big huge book. Although we have index or table of contents, all those things, but this approach would be pretty much faster. Next, what are the technical innovation? So we're going to go with retrieval augmented generations. So which basically which your our chat GPT or any other AI works on chat based models. So vector embeddings means whatever the text that we give, it doesn't understand whatever the text that we give. It is all divided into different vectors. So based on the weights, that's going to understand. So next, modern AI without expensive APIs, right? So it is just you will be using one API key from the Google Studio that I'll show you a demo how you can get one. So if you just put that and if you just go through the thing, So that would be very easy to learn. So what is our traditional approach and what is the AI approach? So traditionally, we need to search through the entire document, or let's say some keyword. We need to search for particular definition of some word. So that is also very difficult. So and it is time consuming, and the chances of going error is also more. And also there would be no context and understanding. Like let's say you would have encountered one big definition, like you would be learning about what is sigmoid and lossy residue, all those things. So you would not know the what exactly that is. So follow up questions would be difficult. For that you need to search in dictionary and or any other source, and you need to understand. So all those things are there in our traditional approach. When it comes to the AI powered method, right? So the large language, so with your simple English itself, it can understand properly and give you the answers instantly. That too with the citations, whatever the citations that are available in the web. So based on that, that will give you that also verified answers. And one more good thing is it will remember the conversation that we are having in that. So that is the regular versus AI approach, um, between the searching of the particular thing in that book. So if I'll have to explain what is the system architecture, architecture is nothing but the flow, like how we going to build this so that our model is responsible enough to answer our questions, right? So first thing is, as I told you, whatever the document that we're going to load, that would be the main Bible for that, main source of data. That would not know anything other than that. So next, as I told you, for the fast scanning, right, here we have so many text. So for the scanning, everyone would be individual vectors. So vector would be one word, database, convert, text. These all would be stored as one vectors. So in FAISS, so this is one of the best embedded memory in memory that is used for AI follow-up conversations. So I'll just show you from where how we can use this. Next is question processing. As a user, you would ask some question. So you would ask what is Python programming. It will find us similar chunks in the internet too, and it will try to match with your question, with your chunks, and it will give you the best option. So next, like we would be using AI generation also, like basically Gemini. So Gemini will generate our answer from the context. See, Gemini is like you are taking your model to the next level. So always scope of the model, if it has the access to internet, that would perform in a different level. So having a LLM just restricting to whatever data you have is the old school approach. But in the new school, in the new generation, what happens is, so whatever the LLMs that we have, that would be overpowered using integration of any of the AIs. In this case, we have used Gemini AI. Mostly people use OpenAI, but OpenAI is paid. We cannot experiment much with that. So Gemini AI would be very much good for the beginners. So next response, as I told, always it will give us with the better answers plus citations. So what technologies that we will use here? As I told you, Open API key is bit costly. We'll have to buy credits of some $10 or something. Only then we can access the things. So next is we're going to use Gemini Pro. So that is free to chat and it will give us the high quality responses too. So the main core of our session is the lang chain. So how we build a AI application framework which will handle the complex things based on the industry standard. So industry standard, what we do is we'll not build everything from the scratch. So we take most of the things from the open source, like Hugging Face, all those things, all the ready-made things, so that that will fasten up our process. So FAISS, is what the vector database which I told you. So the vector database is pretty much important because as I told you, if you are chatting with a chatbot continuously, it is very important for the chatbot to remember whatever the context that you're chatting. Let's say hi, and if you type hi, it will reply hi. If you type your name, hi, I am Satish, so it will say hi Satish. So going ahead, if it doesn't ask the context what I'm talking about, so the responses would be very poor. So as I told you, FAISS is a Facebook's open source tool that most of them use for the context based or vector database thing. Even as I told you, one of my key projects, Postgres migration. So that included actually migration from FAISS vector database to Postgres vector based database. Why? Because as an industry, like to some extent only you can use it for open source or free, but if you start using for millions of users, this gets costly, so we had to build our own database for that also. Next, as I told you, Hugging Face, right? So I'll give you resources also at the end of this session, where even you would be in touch with whatever the latest industry people working or referring to the different techniques. Basically, everything is referred from Hugging Face. Just like how Kaggle is main thing for the data sets and machine learning, Hugging Face is something which is grandfather for AI related stuff. So if someone is good with Hugging Face, they can build anything related to the AI in a very quick span of time. So next is like how the Hugging Face embeddings will help us convert our text to vectors, right? This is also like if I have to convert a text to vector using a Python code, it will take forever for me, and I don't know what are the type of data that's coming in numbers. So like sorting all those would be very difficult. So Hugging Face will handle all this. So next is it's free and powerful, no API limits. No API limits as in you can query as much as you want. It's completely open source and free. So that's why like I've prepared the module also in such a way that even if a beginner, if he's looking into the collab notebook and if he's going through each and every step is properly mentioned, so that even later on when you get time, you can deep dive into that and you can improve that also. So next, as I told you, we will follow 10 very simple steps. So first thing is we'll get a free Google API key. I'll just share my screen, show you how to get a Google API key. We all will get the Google API key. We will put that into the workbook and we will start parallelly, right? And we will see what exactly we are getting, right? Next, I also configured the required libraries for the code to functions and imported everything that we needed. So I've created a simple document also. So that document you can change it at any point. Next is we need to set up the Gemini plus embeddings. Embeddings, why? Because for the context, whatever the chat that we are having, that should remember. So for the context based chatting, this particular thing is very, very important. Next is we need to load and process the document. That is the first and foremost thing. Whatever might be the AI or whatever might be the lang chain. So at the end of the day, it all comes down to what the data that you are loading and what is the document that you are going to process. So seventh step is to create a vector database. Finally, you would be chatting with our Gemini model. So that will give you proper in-depth answers for your LLM. So you can ask questions, you can get answers, and you can try your own documents too. So as I told you, everything is explained in depth in the Jupyter notebook, because there are so many steps, so many coding part. So even if we get confused, and I mean I've made it very clear, even for the absolute beginners who are new to Python, will also easily understand that part. As I told you, I'll be giving you a demo how to get a Google API key, and you need to paste it in your keyboard, sorry, a notebook. That way you are good to go. I'll share the notebook also. Parallelly, we all can run that notebook, we all can understand what exactly is happening. So I'll explain the coding here itself so that I'll show the interactive notebook so that I don't have to manually code and all the repetitive stuff. So I extracted the key coding here so that it's easy for us to just go through that notebook and easily understand many things and also improve the things. So it is very easy in Python. With very few lines of code only, you can achieve big things. Like if I'll have to set up the same thing in any other languages, right? It will take me like 2 hours or odd in Java or any other language. So in Python, because it provides us lot of library support. If you see embeddings, this Hugging Face embeddings is a library, so which is internally coded by the Python team, where if you just pass this model name, that's enough. It will extract the entire thing and it will transfer it to your embeddings. So that is why Python is hot favorite for all the developers, from the beginners till the pro people, right? So, and also as you can see, if see, this is just a simple line, there is no method inside that chat Google generative AI, and you need to just specify the model, that's it. So you have built your first AI model using just 2 lines of code. So this is what is been happening in the current trend. So to process the documents, again, that is also very simple steps. As I told you, we need to always focus on chunking the data. You would be having huge of data, enormous amount of data, but if you feed all at once, the model would be overwhelmed and it can never learn. So chunking of the data is also very important thing, right? So next is, as I told, vectors. We'll be using FVISS, which is Facebook's vector embedding tool, which will store all the context of our conversations. Next, to build a Q&A based system, it is very simple. We have initialized the LLM, so we need to just pass the questions like this. What is Python? So it will give us the answer. So it is very simple code. That's it. With very few lines of code, we can achieve this. So if any one of us have any idea in further improving this, so that we can improve that model also. Here I've just written it for what is Python, but you can try it for the other content too. So next I'll show you the demo script that I have prepared, like Jupyter notebook, X step by step. Next I'll show the each cell. I'll show you how to set up the API key, right? So many of us don't attempt this kind of projects because we don't know, or we don't want getting a API key itself very hectic, or we'll have to pay. But here that's not the case. I'll help you from the scratch how to get a API key so that we all are in the same page and we can get more insights about the AI, right? So next, prepared a sample document about Python programming guide, hardly 250 or 300 words, and also clearly I've shown you the chunking techniques, all those. Next, in the last, I've also included few of the questions: what a Python is, or what are the key features, all those things. So when I ask these simple questions, even you can try asking the model. So sample Q&A, like what is a Python programming? It will give you all these answers, right? And what companies use it, and what are the sources that it's been extracted from. All these things that will be giving you. So let's understand the key concept. Afterwards, I'll just share you the collab notebook, and I'll show you how we can extract Gemini API, and I'll walk through you the code so that we can all run through that, and in future we can improve that as well. So as I told you, any chat model that we are currently seeing is based on RAG, retrieval augmented generation. So what this does is it combines the search plus our AI generation. So at the end of the day, as a user, we need more accurate answer with less error prone answers. So as I told, it uses your documents as the knowledge base. So if you don't give the proper knowledge base, you can expect a flawy response from the model. So As I told you, vector embeddings. It see, as I told you, ChatGPT or Gemini or any other model will never understand your text. Everything is converted into numbers. Based on the numbers, based on the semantics, it understands what you are trying to convert. I mean, what you are trying to convey to the model. Whatever the natural language that we are typing, right? What is Python programming? It's all numbers for that. Based on that itself, it is able to give us answers in such a fast way. So next is like document chunking. Like as I told you, if there's a big doc and if you're trying to put all at once, and if you're trying to expect a good response from your model, that's never going to happen. So even if we saw in autoencoders, if you have a big proper data set also, it's very important that you scale down in layers, different layers, layer by layer. If you try to do it at once, you can try it out later also, you will not achieve proper expected output. So doing it chunk by chunk will always give you more expected results in terms of this. Next is you can maintain context overlap. Context overlap means you would be chatting what is Python programming. In the last you will tell I need to write a program on this. So it will not know what is that this means. So earlier you would have chatted about Python. So it will assume you're asking about Python and it will give you Python code. So that is what your context is. So conversation memory. So it will remember all your previous questions and you can ask the previous questions, and also your conversation can be free flowing. So why this approach is good that we have currently designed is Gemini API is absolutely free, and we are using the local embeddings without having to set up any cloud or server. See, this is a very good this thing for learning. Even if you see the internet for building this simple thing, they will teach you to connect to cloud. All those things are not required here. With just a simple collab notebook, I've just customized it and drilled it down based on my experience so that all of us can easily learn the things. So here I have added a Jupyter notebook, but always going with a collab is what good, because it provides you TPUs which can TPUs and GPUs which can process the things faster in case of you're training something compared to our local Jupyter notebooks. So with clear examples, explanations, and properly working. So what is production ready? Production ready is something which can be used by the users in the real time. So it can handle the real documents also. Like let's say I want to prepare one customized chatbot for the college. So who is the CSHOD, or how many faculty members are there in CS? Like if I'm a student, I want to join this college. So if I want to research about this, instead of asking third party AI, if I go to the college website and if I chat with the customized chatbot there, so that would give lot of insights for the students, like what is the placements there. So all those things that would be there. So that way, like it is not just making the lives easier, but also business perspective, this is something which is growing tremendously. Like building a chatbot like this customized LLMs, people are earning in millions of dollars. So next is like extensible. So you can add more document types, integrate with your web apps. I mean, it is not difficult to integrate with the web apps. You all would have heard about cursor. You need to just download your pickle file, .hpy file. I'll just show you. So if you export that file and if you just put it into your cursor AI, and if you ask it to build a web app for you, that will build it. Or even you can use Streamlit for building the full stack application. So as I told you, in the business, this is very, very, very essential. Even if you go for any food order, Zomato or even Magic Pen. So let's say your order is delivered. Now, if you see, it is completely automated and completely AI. So those chatbots would be answering you, not the real human. So those would be automatically logging a ticket if that order doesn't arrive on time, or if it takes more than the some hours. The chatbots only will intimate the callers, and they would call back and ask you what happened or something like that. So it is completely AI now. So even policies, as I told you. So employee handbooks. Now we give like if I'm saying say I'm joining some company, there would be a lot of employee guides and handbooks. So I can't read all the 200 pages of the rules and regulations of that. So I can just ask my AI to summarize the document and give it to me in few lines so that I get an overview and I can read it whenever I'm free. In education, this is the hot field basically. Textbooks, let's say as a teacher, I want to prepare a lesson plan for so many hours properly, easily, so that even students can understand. For that also, this is a go-to tool. Next is as teachers, we would were having day-to-day research paper analysis. Like someone would have published a new research paper. Recently, Google has published their model and one of the research papers. So we need, if we want to extract the key features from that, that is also possible using this thing. And also course material, study assistants. So for teacher, like if I know that would be helping a lot. Like you have a big module which is lengthy, which is very boring. If you want to make it more interesting, also that can be leveraged using this. Yes, and then it is not just limited to education, it is also can be used in the legal proceedings, case, loss research, document review, legal briefing analysis, all those things. So at the end of the day, everything depends on the data that you are going to feed it into your model. So that I would call it as a knowledge base. So even in the healthcare, if you upload your whatever the tablets that description that your doctor gave, and if you ask that AI, that is still able to answer. Why? Because the knowledge base, the parameters that's been trained on. So that's how it's helpful. So what are the learning outcomes that you will going to have in this is um, a lang chain fundamentals. Lang chain is basically whatever the custom embeddings data that you have, it would be like a mediator that would help yeah, converting your data into proper embeddings that would help in building the LLM. From that LLM, that would help in scaling to your Google Gemini API. That will improve your answers with more citations, all those things. So as I told you, vector database concepts, AI model integrations, and document processing techniques. So currently in our demo, I've included only for the PDF and text file. So you are free to use for any of the document patterns. So practical experiences. So we will be working with real world AI APIs, building end-to-end systems, handling different document types, creating interactive applications. So how you can take it further? So currently, as I told you, it's just limited to PDF and TXT. You can take it to Word or you can take it to PPT also. So you can experiment with different chunks, or you can test your own documents. So you can ask more complex questions based on the knowledge base. So some advanced project, as I told you, you can learn about Streamlit. I would share an article. It's very easy how you can convert your machine learning model into a interface where you can chat with your model, then add multiple document support. Currently, we would be adding one document only. So going ahead, you can add multiple documents. So next is you can implement document upload into the UI. So all these features you can add up. Now we would be giving in a basic how you can integrate LangChain, how you can integrate Gemini. Okay. So as a part of this, if you are building an application, you can add authentication and you can scale with cloud database also if you are giving it to multiple people. So these are the few resources that I've attached. I will also share it in the chat. So that would be helpful. So as I told you, we would be using FEISS documentation for the vector embeddings, LangChains for connecting the models. So Google AI Studio for the API keys. So we will discuss about these questions in a while. I'll just share my Google Notebook. Will open that notebook, and I'll show you how to get a Gemini API key, and we can follow along. Okay. So just give me 2 minutes. I'll just share the Google Colab notebook, and I'll show you how you can get your own Gemini API key, and we can all follow along with the same thing. So I'll just share it to you in 2 minutes. Uh, yes. So I'll just make this public and I'll share it here. So what you can do is you can take a copy of this. So just a second, I'll just cancel my API key so that no, not everyone of us can use that. So I'll just put my collab notebook here. Everyone, can you please open this? I'll give you a demo how you can set up this so that later also you can see through this. Okay. So before that, what I will do, right? I will show you how you can get the Google API key because that is the first and important thing. So I'll just share my screen. Yeah. Just give me 2 minutes. I'll just share my screen. Is my screen visible here? So if you open this notebook, right? Is everyone having this notebook handy? Yes. Can you open this notebook? And you will find a link here. Can you click on this link?
Excuse me,
So if
sir.
you
I
click,
am able to see the screen, but
Satish?
it is very blank.
my screen, is it?
Yeah, it's not visible, Satish.
Now, is it visible?
No, it's still not.
Okay, I'll just share it again. Is it visible now? The team screen?
Yeah, your screen is visible.
Okay. Just give me 2 minutes. We'll go here. So yeah, is the screen visible now?
It's completely blank, actually.
Blank.
Is it? Oh my God. Just give me two
We are
minutes.
able to see you sharing the screen, but I think the window that you are trying to open is blank. We can see only black screen.
Oh, okay, okay. I'll try to open it in
You can
the.
share the entire screen, it seems.
Yeah, I did
Press.
share the entire screen. Uh, if you see here, I'm sharing my entire screen here, right? Can you see the team screen here?
Yes.
Or
Yes,
how do
yes.
I share? Window, presenter mode, screen. I just clicked on the screen. So I'm sharing my entire screen. So now is this not visible?
Your team screen is visible, actually.
Okay. Okay, in that case, I'll have to share it again. I think I might have some permission issues. So I'll just share my browser screen better. Yeah. Now is it visible?
Yes. Now
Okay.
it's visible, Satish.
Perfect. Perfect. So we all would be having this URL, right? Gemini AI Studio, right? Can we all open this? I'll just show you how we can get a API key so that we all can get started. So this is the link. So if you click on this, is my screen visible? The new screen, which create API key.
Yes.
Yes,
Yes.
yes, it's visible.
Perfect. So if you open that Google Gemini AI thing, right? So it will ask you to create a API. Is everyone here till here with me? Can you respond, everyone? At least a thumbs up.
Yeah, they are sending thumbs up.
Perfect. Perfect. Because I cannot see the team screen. All right. So we can click on the create API here, right? So you can click on Gemini API here. Okay. So create, if you click on this, it will create a new API key for you. Any doubt still here? Generating the API key?
Can you repeat it again? I have clicked on the create API key and then
Perfect. So if you click on the create API, are you seeing a screen like this?
yes, it is
Perfect.
loading. I can see a link to copy.
You would see something like this, right? Yeah, you can click on that.
We see some Excel
So
codes
that
kind of
I'll
thing.
help you.
Is it fine?
Yeah. So once your API is created, right, it will show you like this API keys in the below part, where you will have a link kind of thing, as you told, to copy.
Yeah, got it.
Got it,
Thank you.
right? Very good. So can
Sir, can you repeat once again?
perfect. I'll repeat it once again. Not an issue. So here, can you see this create API key, ma'am?
Yes, sir.
If you click on that, this interface would be opening. Next, you will be clicking here. You will be selecting it, and you need to just click on create key in the existing project, or for you, it would be a new project, ma'am.
Okay, sir.
Just you need to click on create. That's it.
But I think, I mean, I got it without using this option. The moment I clicked it, directly that copy option came. I didn't get this
Perfect.
Gemini and all those
Yeah.
things.
Yes.
But I
In that
got the
case,
whatever the output I got. Yeah, I got this directly.
perfect. Then you can just copy this. You can just hit on this
Yeah.
copy icon. So you will get your API keys, right?
Yes. Yes.
Perfect. So now I'll show you where you can embed this thing. So if you come here, you can see here Google Gemini API key. You can just paste it down here. You got this right in the step one. Replace your API key with the actual Gemini API key. And if you run this, you should be seeing API key set successfully. Can you all confirm if you're here till with me? If you are facing any issues, you can share your screen. I'll help you out because this is a crucial step. So if we are till here, it's
It is successfully.
perfect. That is it. That is the
So there
preview.
is a one hand raise.
Okay, ma'am.
Can you just unmute and speak? Who is that? Girija ma'am. Girija ma'am.
Girija ma'am, any else, ma'am?
Yeah. I got the answer. Like, I mean, previously, like I raised, but no one responded, so I turned on my
Oh,
mic.
sorry, ma'am.
Okay,
Extremely
okay,
sorry. Didn't see that.
okay, okay.
So, ma'am, are you able to see this message, ma'am? API key set successfully.
Yes, sir.
Perfect. Perfect. Is everyone else able to see this? At least a thumbs up, please. If not, I'll help you out. You can share your screen and I'll guide you. This is the very important step, without which that would be very difficult for you to follow this tutorial. Because why I made this is I made it very simple because you would need to connect with cloud, a lot of other things. I've just simplified and put everything into a collab notebook so that it's easier for our beginners to follow up. That's why. So yes, I assume everyone have successfully did this, right? So please don't share this API key with anyone else, because you will exhaust all your credits here. So this is something you should keep it very safe, right? So if you're sharing this collab notebook to anyone also, so you need to just take this API key out and you need to share it. That is one rule, okay? So or else you will exhaust all your credentials. You will not be able to query this API if others start using. So as I told you, this is our very first step. Actually, we could have just limited to, I was asked to explain only with in terms of LLMs, but I see that that topic is pretty much outdated. It was like happening 2 days, 2 years ago. But in the current trend, this is what we do. That's why I'm just taking this additional topic also, so that it would help all of us in using the real time also. So after that, uh, can anyone confirm? Everyone confirm if you are here with me till here. Any doubts? I mean, at least for the setuping of this thing. Perfect, ma'am. So I'll just go with the next steps. Even after the session, if you have any doubts, I'll drop my email ID. You can just mail your concerns. I'll just try to reply it as early as possible. Okay. So as I told you, doing any project, we always a repetitive step. First thing is we need to install whatever the required libraries are. So as I told you, for PDF extraction, we would be using this. Then for Gemini, we need a LangChain, Gemini package, then LangChain community. This is the best LangChain module that we can use it for building fast chat bot based applications. Then FAISS CPU. This is our Facebook's open source memory model where it will store the vector embeddings. So then sentence transformers. If you are using any chat GPT or any AI models, you need a sentence transformer for interpreting the good response. So next, as I told you, we are using Google Generative AI. For that, we're going to put this version. So these are all the stable versions. In future, if at all any version updates or anything happens, I make sure that I'm updating this. So you all can preserve this document, so that if there is any updates or if there is any improvements, I'll just keep you posted. So once you run this cell, you will get all libraries are installed successfully. Like before we proceed, so all these libraries are very important. So next is, once we have the libraries, we need to import them and we need to set up our project. So as I told you, we are using LangChain, completely LangChain. So for that, we would be using text splitter for chunking the data, then document loaders if you to load the text txt file or PDF based. You can try it for Word or PPT based also later. For vector stores, we are using FAISS, and Hugging based for embeddings. Embeddings is very simple. As I told you, our chat GPT or Gemini doesn't understand the text. It will understand the embeddings, vector embeddings in zeros and ones, the numbers basically. So we need to convert it to that. For that, we are using Hugging Face. So I'll share the Hugging Face repo. I hope every one of you will refer to that later on. It's like a Kaggle for data science. Hugging Face is for like Kaggle for AI. So you all can refer to that. And to chat with Google Generative AI, our LangChain provides Google Gen AI module also. So memories and chains, all these things we would be importing. So then in the step 4, you don't have to do anything. You'll have to just run this. So just by running this simple cell, you are creating a document. You can see a sample text. In the sample text, this is my knowledge base. What is my knowledge base here? Python programming guide, introduction to Python. So all the small Python definition till here. So what I'll be doing is I'll be storing it like a sample document.txt. If I can expand this, if you see here, right? If you see this icon, folder icon, if you expand that, you will see your files that's been created. Okay, if you run the things. So if you see here, this is my knowledge base. So here I'm giving it like a text. I'm just copy pasting it. Even you can upload a text file there and you can point the part to this. So whatever the knowledge that you give here, basically I'm giving knowledge about the Python programming guide. If someone is absolute beginner and doesn't know about Python, so for him I'm building this LLM. So like how he can use this LLM going forward. So everything would be stored in a simple document.txt. If you run this code, you will see a document.txt being formed here. So that way, so that would become our base character. So it will tell sample document.txt has been created with these many characters. So this is very simple. This is our input part. Now let's set up the AI components. As I told you, there would be few conflicts with the Hugging Face Hub. So I replaced it with Python install transformers. Transformers are very essential for these kind of applications. So we will again run it. So you will install one more um, Python library called transformers, which will eventually help your content do chunking and convert it into different embeddings. So how to set up your AI components? So setting up the embedding model is very simple. As I told you, Hugging Face model. Hugging Face embeddings. If you see here, right, later on you can Google what is all mini V12. So all mini V12 is one of the model, so which is very free, and it is fast, and it is pretty much accurate also, and it consumes very less resources, plus it is free also. So all these are because we need to convert our text to numbers which chat gpt or Gemini can understand. So that's why we need to set up this. It can be set up with just 3 lines of code. So this is that simple. Next, like we know chat gpt generative AI. So see, this is LLM. This LLM is responsible for answering all our questions for the knowledge space. If you see here, right, we are going to use Gemini 2.0 flash. This is the model which is the current good performing model. So temperature means it is like a strictness that you're setting, like how much strict your response should be, how much focused your response should be, is what you're trying to set there. So if you keep more temperature, the randomness would also be eventually more. So like that. So convert system message to humans. So there are so many other parameters also, the that if you hover on this, so you will get more on this. I'll share the documentation links also. So this is how easy to build your AI model within just 2 lines of code, not even 2 lines. So it is very easy. So if you
Excuse me, sir.
build, yeah,
In the setup AI components, in that it's not running, sir. There are some errors.
which one? This
Setup
one?
AI components, fifth one.
Yeah, that would show you some error, but eventually that would be pre-installed. You can try running the next one. This setup
Okay.
here. Okay, here if you run, that would be proper. Basically, here you would be installing. Sometimes this will ask you to restart your Collab notebook. That's not a problem. Okay.
Okay, sir.
If you still get an error, you can just post it, sir. We can just check it out. So if you can see here, as we told, memory buffer, we need memory buffer to remember our conversations. So for that, we need memory key as chat history. So that we everything, whatever chat we are doing, everything would be stored in the variable called chat history, and the output would be called as an answer. So if you read the output, right, this will help you understand what you're actually doing every step. Setting up embedding model for understanding document content. Embedding model is ready. Setting up Google Gemini chat model. So Gemini model is ready. Setting up conversation memory. Memory is ready. All components are set and ready to go. So these are the 3 things. Now you have a clarity like how exactly our AI models works. So first is embeddings, which is very important. As I told you, text to vectors, then your actual chat model, generative AI model, then your chat memory to remember the context. Okay, now that we have set up the document and also we have created the knowledge base also, now what we have to do is we need to load the document and we need to train it. train the LLM. So as I told you, although I have around 250 or 500 characters, so we need to chunk them. So if you have a big, then if you have a very big document, the chunking would be like whatever is the document size by 25% would be the ideal size. So if you see here, this is a very important step, how you load and process the document. So as I told you, text loader. See, if you're trying to load any text file with the txt, we would be using a text loader component. So the text loader component will copy all the text, all the knowledge base into this loader. This loader will further load it into this documents. This document will have all the contents. So if you see here, documents character is 1000 plus. So breaking down into smaller chunks, here we are converting the documents into three different chunks. So next, so example chunk, what is, like we created three different chunks. We need to check what the chunks are looking like. Like I have three different chunks. What each one of the chunk is looking like. If you see one chunk which has 415 characters, that has this content. So content preview, you can see Python programming, right? Just till here. So this is how the chunking happens. Chunking is nothing but instead of putting everything into all the eggs into one basket, you're just segregating it into different compartments. That's it. So chunking is not a big thing. So you will just use your recursive text splitter and you need to just mention these parameters. That's it. So with this just one line, you can achieve the text splitting or chunking, we call it. So after you chunk it into three different chunks, we saw the preview of the first chunk. If you see the preview of the other two chunks, how to see the preview of other chunks? Instead of 0, you can put it as 1. Instead of 1, you can put it as 2. By like that, you will see the chunks, all the three chunks. Here 0 means I've just taken the first chunk, so that you can try it out. So next part is creating a vector database. This is very important for any generative AI model or LangChain model. Building a vector database is a must. So this is very, 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 very important. But it is very easy to. So it is just 2 lines of code again. So it is a Facebook library. So what that will do is from our documents, it will consume all these embeddings and chunks. This is that easy to create a vector database. So once the vector database gets created, we are almost set to use our application. So if you can see here, so test functionality, you can see here a testing functionality, or you can ask, you're asking a test query, what is Python? So it will try to give you the answer. So if I show you the output, it will be more clear. So first thing is it will create a vector based database. So it will take few minutes, not much. So it will convert all your text into numerical vectors. As I told, our chat models doesn't understand text. It will understand the vectors more. So vector DB is created. Database contains three document chunks. We only documented this into three different chunks. So it's up to you. You can also try it out. What happens if I do it one chunk? What happens if I do it 10 chunks? So underfitting, overfitting, all those things you can try it out with the document. So this is just I've given it as a moderate, so ideal use case. You can try it for the extreme and lower use cases also. So if you see here after chunking, so what it is telling, what is Python? It will tell you two relevant chunks are found. See, this is the word. You're searching the word that is converted into vectors and it is trying to retrieve. So it is telling two relevant chunks related to what is Python is found. So if you see the result, so it is giving the results also. Python is a result one, Python programming, right? Introduction to Python programming. So all this retrieval is been happening properly. So our last step is what the very important step. Now that you have built your complete vector, then generative AI, then LangChain, LLM, all the things are done. Now you are going to interact with a smarter system. So what that smarter system will do is it will take your knowledge base whatever you have given the sample document or txt as the main thing, and it will start giving content based on that. So you can see here how to retrieve the data. So that also we are giving. See, whenever you search something, right, what is python or something, there would be hundreds of relevant response, but we cannot show all the hundred of them. So sometimes we need to limit that also. So this we call it as relevant chunking technique in the industry. So relevant chunking technique, if we don't use, we will exhaust all the apis that we hit, which will in turn cost us more money per api cost. That's why we always go with relevant chunking, where we just tell whatever are the top three thing in that, you choose the best one and you just display it to the user. So that's when this relevant chunking. So if you will see very less resources explaining these things in the online. So this is very 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 internal, and it's also very good, the relevant chunking, to reduce the api cost and the cloud costs also. So next, we want, our main intention was like, if I'm a teacher, I want to upload my lesson plan or syllabus copy, or what exactly I can plan, what activities I can plan. All those things you can query it from your LLM based on the textbook or the lesson plan or whatever you upload. So it is that powerful. So that we will be discussing in one more session called prompt engineering, like how you can leverage. Now you learn to building a generative AI tool. Next you will be learning what is a prompt engineering, like how you can put better prompts so that you can get better solutions, better answers, basically. That we will be discussing in the day after session. So that would be very helpful. That would be completely hands-on. We will be talking to whichever your favorite AI model, and we will see how the prompting is important in today's life. So as you can see here, documents are loaded, then vectors DB is created. AI model we are using is Gemini Pro. Memory is also is taking the chat history. Then retriever is also doing the smart document search. Why we need retriever is generally, now if we see it is just 1,000 words, 1,000 lines of information that you have pasted. But when you come to our industry, like we scrape a big amount of data, or we get lot of pos data that we need to chunk, we need to segregate, we need to retrieve. So this processing of this such big data becomes a challenge for us. For that we use a smart retrieval techniques, which I've mentioned one of them here. So you can refer to that anytime here. So this retriever helps in retrieving the content very fast. See, if we have a big, huge content of data, obviously it will take time. But as a user, we don't want to like waste even a single time of our time. We want everything real quick. So that's what the user expectation is. For that, to achieve that, so we're going to use selective retriever, this thing technique, where it would retrieve the results pretty much fast. So last is your output as a user. So you can ask any question to your model, so that would be answering you. So as you can see here, we are just building a qa chain, where you will be embedding the question that's coming from here. So if you see what is python programming, and if you just pass this question here, that will give you the answer, something like this. See, sources used, source 1, sources used, source 2, based on our chunks. Source 3, what is the things that are used? But the final answer is this, right? See, these are the sources that's been used to form this output. That is the beauty of this generative AI, actually, LangChain. So all these are not possible without LangChain. Basically, if you don't have LangChain, that, I mean, building this would take thousands of files, and that would be very complicated, I can say, because configuring each and everything takes hours and days together. But with the help of LangChain, all these things have become pretty much easier. So as you can see here, I just asked what is Python programming language. It says, it gives a response like this. for this response, to give this response, what your AI has done internally, you can see here, it has referred to source 1, it has referred to source 2, and if it has referred to source 3 also, like this. So you can change the information, you can see what are the things that your AI is referring when you're asking particular question, all these things. That is why I wanted you all to generate a Gemini API key and pasted it, so that even afterwards you can use this code, you can improve it, and you can use it in the day to day. And yeah, you can ask similar questions like this, it will show you what are the sources that it's been using. So like this. So you can try it out for other questions also. Here it is just related to Python, so that it's common for us, easy to relate. That's why. So if you just type the questions like this at the very end, so it will answers all the things related to the source that you have put. So you can see here, this is what our AI is answering based on the knowledge base that we have given. So you can try to upload different PDFs, research papers, manuals, and you can try to run this code. So this is about this one. I know, like, these are the topics that actually cannot be covered in 3 hours, but I tried my level best in conveying, so that even you can try it out hands on. Only when we try it hands on, we will remember most of the concepts. So I request you all to take this as a task. Just spend 15-20 minutes on this, so that you will get a clarity how your chat gpt is working, and how you can make your work even more easier. Like when we have to know, when we have to get a better output from something, we have to know how it is working. So knowing all these things, exploring all these things will give you a wide knowledge base that will actually improve you as a person. Like always, as in the day to day life, they say it is not AI and humans, it is the person with AI, and it is a person who is not using AI, makes a lot of difference. So I request all you to go through this collab notebook, generate your this thing, and you can mail me anytime. I would be free to respond to that. Or if you have any ideas to build any of the application related to this, you can just contact me. I would be really very happy to help you all out. So this is it for the session on the Lang chain and Google Gemini, where we build our own customized LLM. So I try to make it as simple as possible. So if any questions, you are free to ask. So please. Any questions?
So participants, if you have any doubts, you can just raise your hand or you can just unmute the mic and ask a question. Satish.
Yeah.
I think,
So
yeah, I think, okay.
yeah, ma'am.
Nobody, there
So
are no queries even in the chat box.
okay. So I've just shared the collab notebook and even shared the steps to get that working. If anyone has any doubts, they can feel free to reach out to him. I'll be happy to help them out. So I have one feedback, this thing to be shared here, ma'am. Can
Yeah,
I
yeah, sure.
request all
You
of
can
you?
put it in a chat box. We will
Yeah.
just forward it in a group as well and keep it open till 6 o'clock so that everyone can actually fill it.
Okay, ma'am. I'll
At
share
least
the
6 or 7
feedback
till
as
7 is
well as
also fine.
the
Yeah,
quiz,
quiz
ma'am.
part.
So yeah,
Yeah,
the top performers will get like
yeah, yeah. Yeah, we have announced that.
so, ma'am. Yeah, if any doubts, I'll just put my email also here, so they can freely contact me. I'll help
Yeah, you
them
can
out.
also share your contact details like through mail
Yeah,
or through LinkedIn ID,
yeah, ma'am. I'll
something
put my
like that.
LinkedIn ID here.
Yeah,
So if I paste the feedback link and the quiz here, is that fine, ma'am?
yeah, yeah. You can share it here only. So I'll
Okay.
forward that into the group.
Sure, ma'am. I'll
Are
just
you there in
paste
the
it.
WhatsApp group, Satish?
No, ma'am.
Okay, I'll forward. No problem. You can paste it in a chat box.
Okay, okay, ma'am. I'll just paste it here. So, any other questions, ma'am, from anyone else?
So
If anyone has
hopefully,
any access related to issues, anything, ma'am, you can just
yeah,
ping.
sure, sure. So even I'll put it in the WhatsApp group if any queries. So I'll just put forward to you.
Yeah, ma'am.
Yeah, thank you so much, Satish, for the deep. You actually let us to know all the concepts in a deeper way, and also for the very good and nice explanation of the hands-on. So thank you so much, Satish, for actually sharing all the knowledge with all our participants. Thank you so much.
Thank you, ma'am.
Yeah, could you please leave a link for that feedback and quiz?
Yeah, ma'am. Just a second. I'm just pasting it here.
Yeah.
Hello, sir.
Hi, sir.
Sir, actually, I'm a second year student from
Okay.
BIT itself.
Okay.
As your introduction, I heard that you have participated, you are a winner and at SIH. This year, we are also selected to SIH.
Oh,
So
great.
I needed some guidance for that. Can you if you can tell here, it's fine, or else I'll contact you through LinkedIn or number.
Yeah, you can contact me through LinkedIn. I have a
Yeah,
few important, I mean, easy hacks how you can get into SIH and all. So you're
yes.
always free to contact me. Okay, I'll just paste
Thank you,
all
sir.
the details here. Okay, I'm really happy that and wish you all the best on that.
Thank you, sir.
So yeah, I'll just drop those files here. And sorry for the delay. I took extra 1 minute. I'm extremely sorry for that.
No problem. No issue. Satish, otherwise, will you send it to me so that I can forward in the group? No problem if it is not in the chat box.
Okay, ma'am. Like,
Will you? Yeah.
can I mail you, ma'am?
I'll just text you.
Okay,
I have your number.
okay.
You
Yeah,
can
ma'am, that would
just
help me.
send me the link.
Uh,
Okay, so
yeah,
that
ma'am, I'll
I'll
share
share
you.
it in this entire group.
Basically, those are the QR codes. They can just scan and
Okay.
they can give it. Shall I ping my number here, ma'am, or you have it, ma'am?
I have your number. It's there in the resume, right?
Yes.
Okay. I have your resume. I'll just, otherwise, Naman will give me. No problem.
Okay. Because I'm not able to share it here because I'm an external
No
person.
problem. If it is okay with you to share in the chat box, you can also just do that. No problem.
Yeah, in the
I think
Teams, since I'm
I
an
have.
external, I'm not able to share it.
Okay, no problem. Satish, I'll just text you. I have your number, I think.
Okay, ma'am.
Yeah, I'll just check out. Okay.
Okay, ma'am. If you
Okay.
just
Shall
ping
I?
me, I'll just send you all this, ma'am.
Sure, sure. Okay.
Okay.
Thank you so much, Satish, for the wonderful sessions. So it was actually indeed in depth. I mean, whatever the knowledge you have shared, right, that was really wanted to everyone. So thank you so much for the hands-on session. That was really good.
Thank you, ma'am. And thank you, one and all, for being very patient for this 3 hours.
Okay. Thank you. Thank you, Satish. Thank you, one and all. So I'm just going to end the session now. So we will meet tomorrow.
Ma'am, the feedback and the
Yeah,
quiz will be
feedback
put in
and quiz
the
will
group,
be,
ma'am.
yeah,
WhatsApp group.
link will be shared in the group.
Okay, ma'am. Thank you.
Okay.